Hello guys, how are you all doing? So my name is HOZINTH RAO and I'll be presenting you guys about past year question 9 chemistry. This question is a huge question, it carries 16 marks. So let us go right through it. Okay, so this is the question. Based on the question, by looking at it, it looks kind of hard, but after we go detailed, it's not that hard at all. It's actually a very simple question. It's a very basic question. So let us go right through the question. So the first question is define standard solution, equivalent point and endpoint. The keywords are standard solution, equivalent point and endpoint. So this is a definition question. It's about your memory or your understanding. So standard solution is a solution containing a precisely known concentration of an element or substance. Equivalent point is the point at which there are equal amount of moles of hydrogen peroxide and hydroxide in a titration. And endpoint is the point at which the indicator changes color in a titration. As I said, this is an easy, basic, straightforward question. So the next question, A2, the question asks what is the pH at equivalent point Z for this titration. Okay, so they ask the pH at equivalent point. So based on the before question, we get to know that equivalent point is the point at which there are equal amount of moles, which means it is neutral. So when neutral, we know that the pH is 7. So this is actually a 1 mark question. You can just write 7, but just for explanation purpose, I wrote that 7 because the solution is neutral at equivalent point. Moving on, the next question is calculate the molarity of the NaOH solution used in the titration. Okay, step 1, we have to write down the equation with the correct state and make sure the arrows and the elements are all correct. So next thing is we need to know what formula to be used. In this case, it should be MAVA or MBVB equals to A or B. So then next we replaced the values into the formula and we'll get that MB, which is the molarity of the NaOH solution, is 1.125 mole. Do not forget the unit, guys. So moving on to the next question. Calculate the pH of the solution after the addition of 25 ml of HCl. So they ask calculate the pH and after the addition of 25 ml. So first of all, you need to find the new mole of HCl, N equals to mv per 1000. So based on that, you will get the new mole, which is 0.025 molarity. Again, unit is very important. And next we write down the equation again with the correct state and only a single arrow because it's HCl and NaOH. And the next step is we form an ice table. So as you can see, the ice table is formed as below. And remember that the total volume has now changed to 45 milliliter. So for now it's not bad at all. Let's just move on. So after that we replace the mole into the N equals to mv per 1000 formula to get the molarity or the concentration of HCl, which is 0.056 molarity, the new molarity. So and then we know that pH equals to log of the concentration. So pH equals to negative log of the concentration, sorry, and then you will get that pH is 1.2549. The B question carries 7 marks, so it is a huge question. However, it's not that hard. Let's go through. So the question is pyridine C5H5N is a weak base. This base ionizes in water to produce C5H5N plus and OH negative, OH minus. Calculate the pH of 1.00 mole pyridine solution if the dissociation constant Kb of pyridine is 1.5 times 10 to the power of -9. So First of all, we identify the key point. Pyridine is a weak base, so it ionizes to produce C5H5N plus and OH minus. So what the question asks is the pH of the pyridine solution, and the information given from the question is the Kb of the pyridine is 1.5 times 10 power negative 9. So first of all, please state the equation with the correct state, and don't forget it's double-sided arrow. It is a reversible reaction. So next we form an ice table, as you can see, and then we get to know that Kb is equals to product concentration of product or concentration of reactant. So we list that CH5N plus times OH negative over C5H5N, and then we substitute all the values into the formula. However, do not forget that 1.5 times 10 negative 9 is smaller than 10 to the power negative 5. So the Kb is very small. So we have to assume that 1 minus x is equals to 1. So that leads us to 1.5 times 10 power negative 9 equals to x square. So x we will get 3.873 times 10 to the power negative 5, which is the concentration of the OH. So when we get the POH, to get the POH, we replace the formula that negative log of the concentration. So we'll get the POH is 4.412. But do not forget, guys, the question is asking about pH. So we all know that pH plus POH is 14. So pH equals to 14 minus POH. So 14 minus 4.412, you'll get the pH of the pyridine solution, which is 9.588. Remember, guys, pH does not have any unit. So as you can see that the question is not so hard at all after we go through detailed. So that's all from me. Thank you, guys.
That's all for this video. Please do remember, subscribe, like and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.